Actually drone mapping, and I have with me Mr.
Hi everyone, my name is Krishna Loda. I am from Nasik, Maharashtra. I am the founder of Rotten Grapes Private Limited, and we are into open source geospatial development and geo AI. And I'm really glad that we are doing this training, hands-on training today. This will be a hands-on training on QGIS, which I think, like, if anyone is interested into understanding what the heck is GIS, I think the first step is QGIS. Like, QGIS it's kind of like a tool that will allow you to visualize as well as see the data, analyze it, and also create reports. So it's kind of like when we started learning computers and Microsoft Word or Paint was our first software. So if you are now learning GIS, QGIS will be your first software. So yeah, next slide.
Yeah. Also, just to mention, with us we have our volunteers. So Ms. Sahana is there, Sia is there at the back. We have Jaden and Samuel. They all will be assisting us today here to conduct this session very effectively and smoothly. So now we will begin the sessions. So the sessions are structured. Okay. First, there will be some theory session that is covering the essential concept which you need to understand. Okay. Then there will be an end-to-end demonstration of that concept. Okay, at this time we expect you to pay attention. Once that is done, then there will be a hand-holding session where we will repeat the steps for you to follow. Please don't follow in the first end-to-end session. Okay, you will be instructed when you have to do the step. Okay, so this will be the flow, and there will be a summary, and then we will move to the next session. Okay, so we will begin now.
Okay. At any point, if anyone has any questions, you can raise the hand and someone will reach out to you. So for us, the agenda of day one would be introduction to QGIS, then what are data models in GIS, projections and reprojections, and finally we will wind up with georeferencing. Also in georeferencing, we have two submenus. We will be doing image to map and image to image registration. This is going to be a very amazing thing for anyone who wants to get into the GIS, because by the end of this session, you will at least see the data on your map or on your computer, and that's really exciting. So a bit about QGIS. It's an amazing tool which is installable in your Windows, Mac, Ubuntu, and it gets the analysis as well as visualization job done. But one of the most important thing that I feel about QGIS is it's totally open source. As ourselves, we are an open source company. We believe in using open source product for our enterprise level customers as well. So having said that, we have worked with a lot of clients where they are dealing with very heavy data sets completely using open source. So that means you have a tool in your hand which is absolutely free of cost for you to use. So we'll see how to install QGIS. We will understand the QGIS interface, and then finally how to add plugins to QGIS. So one of the advantages of using this software is that you are not only bound by the limitations of the QGIS developers. If you have a particular use case, for example, if you are from hydrology department, or let's say you are from the cadastral mapping department, or maybe a disaster department, and you have to create your own workflows, you have to create your own algorithms, you can do that, and you can open that for the entire world. So you can create an algorithm or create a plugin that anyone in the world can open. And that's the beauty of using QGIS, is that the entire ecosystem is built on top of people contributing. Next step. We'll again go through the bits and pieces of what are geographic information systems. From the morning, like we all have been hearing about, how the data is being collected, whether that can be a satellite which can be very close to the earth, let's say like 900 kilometers, or which can be something like 36,000 kilometers above the earth. But the thing is that that's all about collecting the data. What then comes into the picture is about how do we use that data and how do we make sense out of that data. We all have heard this phrase that data is the new oil, and that is absolutely true. But now it's becoming that what do you get out of that data is the new oil. So data is available everywhere. You can get the satellite data from all the way up to 2000 or 2008 till today. You can get all this data for free of cost. But what sense you make out of that data is really important, and that's what GIS is all about. So GIS is a tool that enables you to take that data and make some kind of sense out of it. It can be via visualization or it can be via analysis itself. So we will see how, like in QGIS, you can create interactive maps, you can use queries, you can analyze the data, you can also edit the data on the fly, and you can present it in the reports format. Next. Installing QGIS. In your case, everyone will have QGIS installed on their machine, but if you don't have it, or if you want to install it in your home computer, you can just simply Google QGIS and you will see the link. Or this is the link that you can also follow. You can just go to qgis.org and download it. I have been using it on Mac as well as Ubuntu and Windows as well, and it just works very, very good. So no issues there. So as you can see, you can just go to the QGIS website and download the LTS. So long-term versions are always interesting for most of the people, because whenever a new version comes up, they roll out so that people can test it out on different machines, different use cases, and then they can report the bug. So if you want always the latest, then you can go for all latest versions, but they might have bugs. But the long-term versions would be the versions where most of these bugs are resolved and you will get a very stable version. So yeah, next one. The interface. So we will now see what is the interface of QGIS looks like. Now this might be different on each one of our computers. There is a standard interface, of course, with QGIS, but that doesn't mean that we have to live with that. Just like how we all have our separate themes on our computers, or maybe we use different kinds of things. We want to have some things with us right on the interface, while some things we want to have as a drop down. So all these settings we can play in QGIS. But overall, you will see that when you open QGIS, you will have the toolbar at the top where most of these settings are. Again, they are trying to follow the same kind of interface that you will have with Microsoft Word or Paint or something like that, where you have the majority of the categories at the top. When you click on those, then you will see more information about this, like this. So plugins, you can see there are different types of things. In layers, again, there are so many options. Then you have some of the most widely used icons. So these icons actually represent the various things that we do on almost everyday basis. So for example, you have get information icon. That means when you will click on any feature, after clicking on this icon, you will be able to get the entire information about that particular feature. Then you have attribute, then you have measurement, then you have your Python console, so on and so forth. So you might not see all of these icons in your toolbar, and that is completely fine. Some of these things we have added as a plugin, and some of these things might be hidden in your computer. Then after that, you have browser. So browser will allow you to go to your computer and get some files. If you scroll down in the browser, please. Can you scroll down? Yeah, more. Yeah, keep scrolling now. Yeah. So apart from your computer, you can also connect. If you have a database, you can also connect database. If you have a WMS instance, you can also connect with that. XYZ, vector tiles, etc. So browser, in short, allows you to connect external data with your QGIS. That's the base. Now, whenever you will add any of the layer on your application, you will see all of those layers under the layers panel. So this is where you will deal with the active data that is there on your QGIS. So this is all about available data, and this is all about active data. Now, when we will actually have the layers, we will talk more about that. And then another interesting thing that is there in QGIS is a toolbox. So toolbox is something that makes QGIS very powerful, because you can do very, I would say, difficult or in-depth analysis using this toolbox. And as you can see, there are a lot of like analysis and tools available in this toolbox. Some of these tools are shipped with QGIS directly, and for some you can just install plugins. Now, if you go on this empty area and if you just right click, you will see all the options available. So this will allow you to see all the options that you can turn on or off in your QGIS depending upon what you need. So we will just try to maybe turn on any one. Maybe you can go to, I don't know, layer styling panel maybe. Yeah. So you see that something popped up. We don't have layer at the moment, so that's why it's not useful. But now you can just right click on an empty space again and remove it on the top. Yeah. You can just in the empty area, maybe somewhere. Yeah, toolbars you have. Yeah, and then just turn off your layer styling panel. Yeah, it's gone. So we can just turn on and off all the toolbars. Can you go to the presentation, please? Yeah. So this is about adding different tools and also about the interface of QGIS. Now, should we stop? Yeah. And the last thing that we will cover in the introduction to QGIS is the plugin. So as I said, plugins allow us to create new things which might be very specific, use case specific things, but that they can be exposed as a plugin so that anyone in the world can can use it. So let's see what plugins are available. If you go to these plugins and manage and install plugins, you will see. Can you cancel this? Yeah, you will see all the plugins that are there which are available in the QGIS directory. So think about it in this direction that when you will create a plugin, you can submit it to QGIS and ask them to put this in their official plugin library. But obviously, if that is a very small plugin, or let's say if it's a plugin that probably masses will not use, they might not accept it. But that doesn't mean that you cannot share your plugin. You can always create a zip and share that zip with anyone, and they can just install the plugin via zip as well. Having said that, we will install one plugin, that is Quick Map Service. So if you search for Quick Map Services, you will see a plugin. If you click on a plugin, you will see that this plugin will allow you to add various base maps onto our application. So at the moment, you can see that this is entirely white canvas. So we have no layer, nothing. So it might be a little bit confusing, where is the map? But if you install this plugin by simply clicking on it, and you will see the install button over here. Since we already have installed, we are getting reinstalled. But once you install and close this, you will have the plugin with you. And now if you go to the web Quick Map Service, and you will see all the base maps that are available. We'll go to OSM and drag OSM standard. So as soon as you click it, you can see the map as well as you can see the layer available over here. And that's what I was mentioning about the layer panel. Now you can simply zoom in, zoom out to the location that you are interested in, and you will see the OSM data starts appearing. Just like OSM, if you are using Mapbox or MapTiler or MapLibre or even Google Maps, you can bring those base maps into your QGIS. We will have a look at that in the future, that how we can add it, or maybe we can just drag it and see it. And now you can see that we have two layers, and if I want to bring this layer on the top, I can just simply click on it and drag it, and my OSM standard will be on the top. So this is some of the quick, I would say, hack in order for us to manage the layers. So yeah, this is all about introduction to QGIS. Thank you.
Now we'll request the participants. You can move your cursor onto the interface, see the names popping up, okay, and then Sana will help you on installing the plugin Quick Map Services, and we expect you to add one layer onto your map, okay. So now Sahana will show you how to add the plugin. Yeah. So to add that plugin, okay, you see a menu plugins. So go there and you have to click on manage and install plugin. So you'll see a dialog box. Everybody can see a dialog box like this now. Anybody who cannot see, just raise your hand so our volunteers can reach out to you. Okay. So here on top in the search bar, okay, first you keep that on the side, you click on all, okay, and then you type Quick Map Services, or if you just type Quick, you will get a list of plugins matching that name, and you select Quick Map Services. If anybody is lagging behind, just raise your hand so that a volunteer can reach you. They have typed quick map services in the search bar. Okay. Now select this quick map services. No space, okay? Don't keep any space. Quick map services is one word here. Don't keep any space. Okay? Okay, that is some of you may be facing the issue of network. Okay, so to install the plugin, you need to be connected to the internet. Okay, so that is the reason why some of you are not getting the drop down. Okay. Okay, if you are facing some issues, it's okay to work alongside your neighbors, okay, so that you both can collaborate as well, okay. So please understand, if you are not getting the search, it might be a connection issue, internet connection issue. So what I want you to do is, go ahead and click that button there, install plugin, okay, click that button, install plugin. Okay, so I suppose you all have been able to install the plugin. Now, you might wonder where this plugin is available. Okay, so once you install the plugin is available in one of the menus. Okay, so you have to go to web and then you'll find the plugin installed over there. So whenever you install plugin with QGIS, it will be available in one of the menus. Quick Map Services plugin is available in the web menu. Go to web, go to Quick Map Services, and there you will see some layers available. Okay, just click on that layer to add it to your map canvas. So go ahead and add the OpenStreetMap layer OSM standard. You can see Sahana showing you where to add it from. Sahana, can you go to web, Quick Map Services, OSM, OSM standard. So I want to see on all your systems the OpenStreetMap loaded. You can zoom in, zoom out and test the interface. See, many of you are having a problem with the sizing, right? Sizing of the dialogues box. It's done. Installed. You don't have internet access. So you can work with somebody alongside someone else. internet access is not allowed. Okay. Test the interface, zoom in, zoom out, see, try to find, zoom into Goa. Okay, get familiar with the interface. Anybody who has not got this, please raise your hand so that our volunteers can come to you. So there is one more thing what I want to tell you is, many of you will notice when you go to web, quick map services, you are not seeing all these data set, right? Many of you will not see most of these data sets. Now to get those data set, there is a little one more step, okay? So I'm going to show you what that step is, okay? So you go to quick map services, okay? Then go to settings, okay? Click on settings, do it. Go to quick map services, web quick map services, settings. You will see a dialog box like this, okay? In this dialog box, you will see a tab there named more services, okay? There's a tab named more services, and then there is a bar down which says get contributor pack. Click on that get contributor pack. Once you click, you will notice that a lot of more data set is now available, okay? So Sana will demonstrate one more time. Okay. Okay, everyone. Okay, I need your attention now. Whatever steps we are doing, we have given you a detailed step-by-step guide. Okay, so how to do it is already there with you. What you must understand more is why we do certain steps. Okay, so focus on that. We can you can take your time when today's session is done. Before you come for the next session, you can take your time and go to the step-by-step manual. So we'll be going a little faster from here. Okay, understand why we do certain steps. Okay, how it is done, you will have in the step-by-step manual. So there is a PDF there given to you. So what we are doing now is we'll just go ahead with the next module. Okay. So I'll be starting with the next module now. Okay, now I need your attention. Just stop what you are doing now on the laptop so that we can understand the next concept. Okay, please stop. If you miss the information, you will not understand what we are doing. Okay, or why we are doing certain things. So you stop now. You will have time to revise that. Okay. So now we'll start with the next module. I want everybody's attention. Please stop looking at your screen now so that you understand why we are going to do the next steps. Okay, what we are doing you will know from the manual. So now let us try to understand data models. Since morning you heard people say satellite data, right? Field data, GPS points, all this is data. But the data comes in different forms. Okay, there are two most common forms of data which you will work with in GIS. Okay, now when I say GIS data, okay, it's different from your traditional data in the sense that there is some spatial element, right? The data has some location. This is what makes it different from other data. Now when you come to GIS, there are two common forms of data, raster and vector. Okay, so I will explain to you what raster data is and then what vector data is. So when a satellite is imaging from top, okay, it generates data which is in the form of pixels. We refer to this data as raster data. So you must have noticed even when you click a photo and when you zoom in, and then you will see the square pixels, right? So that kind of data is raster data. If you take an aerial photo, it will give you raster data. If you have a plan and you scan it, again you will have a raster data. Okay. So this kind of data is called raster data and it can be used to represent many things. Here you see a true color image. It could be a sensor which is detecting heat, and again we can represent in the form of squares, okay, in the form of pixels which indicate heat values. Rasters are also used commonly to show terrain data where the value in the pixel indicate height of features on the ground, right? So all these forms of data which is typically in the form of pixels is called raster data. Okay, next slide. Next is vector data. Vector data comes in three forms. We call that geometry. It can be either a point, line or a polygon. Okay, this kind of data we refer to as vector data, and vector data has two elements. Okay, one I already mentioned is the geometry, which can be a point, line or a polygon. Second part of the vector data is called the attributes. Okay, so let me explain. Say for example we intend to map wells in a village, right? We have to first decide what are we going to use to represent these wells. Are we going to show them as circles or points or polygons, right? So typically we would decide, let's represent wells with a point, right? So the geometry here is the point. Now you might say, I want to know, or when I collect the data, I want to know whether this well is used for drinking or no. Who is the owner of this well? What is the color of this water? What is the depth of that water table in that well, right? This information is called attribute. Okay, attribute information, right? So if I was supposed to map roads in my village, which geometry would you prefer to represent roads? Line, right? Attributes, what could be some of the attributes of the road? Whether it is tarred, Yes, how wide is the road, okay, whether it is tarred, not tarred, right? These are the attributes. So all vector data will have geometry and attributes. Is it understood? We will be shortly exploring some of the data, okay, and explore the attributes and also the values of pixels. Next. Okay, and the third part is the concept of layers. All this data, when we bring in a GIS application, it needs to be organized. Okay, as Krishna showed you before, the layers which are on top will reflect above all the other data. Okay, so the best practice is when you have point, lines, polygon and raster data as a base layer, points will be right on top in your ordering, then you order the lines and then polygons, and then if you have a base raster. Okay, so we will actually do this exercise practically and see now. Okay, so first I would request Sia to show how we add vector data. Okay, so let's go and see. So back to QGIS. First thing, I want you to start with a new project. Go to project and click new. Okay, so go ahead everybody, click on project and new, and discard your changes, whatever. You don't have to save for now. Start from a blank slate. Okay, so everybody should have this, and we'll start with the demo. Okay, now Sia will show you how to add a vector layer. So she goes to layer, then she goes to add layer, and then she goes to add vector layer. Okay, now there is a dialog box which opens and it says source vector data set. Okay, she will click on these three dots and find the location in your local system where this vector data set is stored. So here we go to exercise 2 folder, which has a folder named vector. You don't have to do these steps now. Okay, vector, and here we have Goa villages, a vector file. Okay, click add, close. So we have been able to load the village boundaries of Goa. Okay, now before you do this step, I want to convey the concept of geometry and attributes. So what is the geometry here of the features? Is it a point? Is it a line? Is polygon, right? So each of these polygon represents a village. Now using the identify tool, okay, you click the identify tool and click on any polygon. Okay, what you see here is the attribute information, right? So one of the attribute is the name, which is the name of the village, and the district, which is North Goa. The attribute data is associated with the geometry. Okay, this is what makes GIS very interesting. So now I want you to go ahead and add a vector data set. So you will follow the steps what Sia is doing. Okay, go ahead. So go to layer, add vector layer, and hold on. Okay, layer, add vector layer. So everybody click that. Okay, next. So a dialog box you will see. Under the source parameter, you need to click the three dots. Go ahead and click the three dots, and then navigate to the exercise 2 folder in your data set and select the Goa villages.gpkg file and click open, and then you can add, click on add and close. Don't forget to click on add, okay, after you select the data source. Go to vector. Next we'll show you. So everybody will see the village's boundary on your interface. Need not be in the same color. Okay, the colors can be different. Okay, so this is how add the vector data. You can go ahead and explore the attribute information by clicking on the identify tool, that icon, then click on any of the polygon. Identify tool is here. This one. Yeah. Click on any polygon. So we have explored how to add vector data and also to check the attribute information. So I'm just demonstrating how to check the attribute information. There is a tool on the toolbar which is an eye icon. Okay, you need to select that. Okay, and then you can click on any of the feature after selecting the eye icon for identify tool, and you will see the attributes in the attribute panel there on the side. There is also another way to find the attributes. Okay, in the layers panel there is another way to explore the attribute information. In the layers panel, you select the layer, right click and say open attribute table. Go to layers panel, right click, open attribute table. So click, you will see the attribute information associated with the entire data set. You can minimize this attribute table, you can dock it to the bottom. There are many things you can do. So the interface is quite customizable. Okay. So now we will move to the next data set, that is adding a raster layer. Okay. So everybody, now I expect you to stop what you are doing. Okay, stop what you are doing, pay attention. Now in a similar fashion, we will add a raster layer. Okay, I have provided you a data set which represents the terrain. Okay, elevation model. So to add the raster layer, we again go to the layer, add layer, and this time we choose add raster layer. Okay, so go ahead and click add raster layer. Now you will have a similar dialog box with the source parameter. So we click on the three dots at the right, and then this time navigate to the raster folder. Okay, in exercise 2 there is a folder named raster which has a raster file. So we will select that and click open, add, and close the dialog box. So you will see the raster layer now. Okay, so go ahead and quickly add a raster layer. So the data set that you see is a raster layer. If you zoom in, you will be able to spot the pixels. Okay, if you zoom in, you will see the layer is made up of pixels. You might be wondering what this layer is representing. This is a digital elevation model layer, okay, which represents the terrain. If you have zoomed in a lot, you will notice that it is made up of pixels. each pixel has a value which represents height. Okay. So now if you want to explore that value, you can use the identify tool. But remember, the identify tool works on the active layer. Okay. So first you select the layer. Okay, if you want to use that identify tool on this layer, then click on identify tool and now click on any pixel. After zooming in, click. So here you will see the elevation value. Okay, so this is how raster data works. Okay, in GIS. So you will see here in the current representation. Okay, lower values or the less elevated areas are represented in dark colors and the higher areas are represented in brighter colors. We can modify this coloring, okay, based on the pixel values. So that we will do in a later exercise. Okay. Now you might be wondering, where is the villages data set which we had loaded? Now remember what I told you about layer ordering, right? So the layers which are on top will be seen above all the other data sets. So in this case, what has happened is Goa SRTM is on top, right? Which is burying the first layer that we had added. So go ahead and just select and drag, okay, without leaving your right click button. So select and drag it above the SRTM layer. So now you have understood how the vector data works, how the raster data works, and layer ordering. Okay, these are very key concepts in GIS. Understanding vector data, its attributes, okay, raster data, and layer ordering. Anybody has any questions with regard to this so far? No? So there are many ways to add these data sets in ArcGIS. We will show you later when we do other exercises how it is done. Okay? So far so good? Okay. Then we'll be moving to the next exercise. Also, the one more thing that I want to just mention is in the layers panel, you can switch on off layer visibility by just toggling on this checkbox. Okay, so you switch on off, it will either show or make it invisible. So much of GIS knowledge will come from experimenting like this. Okay, so you need to go and play around with the tools. Okay. So I think now we will move to the next session. Okay. So a very important concept will be covered by Krishna now. Please pay attention. So stop now. Whatever you are doing, stop. We will cover the next concept.
Yes. So this is going to be the one of the most important concept that you might need to understand when you come to GIS as a domain. And to be honest, this is little bit tricky, I would say. But at the same time, if you understand like what is coordinate reference system, I think that will open up a lot of door for imagination and all. How many of you guys are a flat Earth believers? Are there anyone who thinks that the Earth is flat and not round anymore? Okay. None. I think that's good, but to be honest, I do that. But I'll tell you why. It's just it's a fun way to look at the Earth. Now, what exactly is coordinate reference system? Okay, how many of you believe that the Earth is kind of like round or sphere? Yeah, everyone. Okay, but like how many of you believe that it's an exact sphere and there is, you know, like no deformities whatsoever? Yeah, exactly. So, yeah, when I go to conferences, I ask this question, and when I go to like Europe, there is at least one guy who say that, okay, I do believe in flat Earth. So I had this, you know, entire gig prepared for that. Anyways, coming back to the main thing, if you have orange at your home, if you go there, try to peel it in a way that you can lay out the orange skin completely flat. This is the way you will do that, and this is what is a projection is all about. Projection is about how do you imagine something which exists in 3D, which is, let's say, our Earth, which is in 3D. But if you have seen our QGIS, that's a flat 2D, right? And most of the time, whenever you take a printout of the maps or when you look at the web maps on any of these portals, you will see that the maps are represented in 2D. So how is that possible? The world itself is 3D. And that is where the concept of coordinate reference system comes into the place. So concept of coordinate reference system can be divided into two things. One is geographic coordinate system and one is projected coordinate system. So geographic is the one which consider Earth as a 3D object, whereas projected is the one that consider Earth as a 2D object. Now you might say that we all know Earth is 3D, so why to you know go and do the efforts on creating something like projected coordinate system? But let me tell you, 99% of the time we do consider Earth as a flat when we work in GIS domain if you are working on a global data set. Now let's have a look at both of these things. So while creating a coordinate system, we have to understand that no coordinate system is perfect. There are thousands and thousands of coordinate systems, but none of them is perfect. Because in order for you to have a perfect coordinate system, you will have to have a system which can give you the exact lat long, or let's say exact location of anything, as well as when you have 2 or 3 of such locations, it should give you the exact length or area between these multiple points, which simply does not it's not possible, because Earth is round, so you'll never get the exact correct length. And that's exactly why whenever we are considering the global data set, we consider Earth as kind of like a flat, and then we do all of our calculations. And obviously these calculations are not all the time correct. So if you see the distance between New York to Mumbai on a flat line versus on a curved line, it will be very different. But the reason why we want to understand is this, that whenever we will work on our project, the first question that we have to ask ourselves is, what is the scope of my project? Am I creating something which will be only relatable to the Goa, or am I creating something that will have data all the way from west to the east, like all the entire world? If your answer is that you are creating something which will serve the purpose for the entire world, you will have to consider Earth as a flat and then use the projected coordinate system. Whereas if you use something like a, you will have to use the geographic coordinate system. And if you are going to do something like only specific to a place, like let's say India, for that matter of fact, if you are only focusing on India, then you can consider Earth as planar one, and then you can use the planar coordinate system. Because when you will do that, your projection will try to make India the best way possible. So all the locations that you put on the map, all the length that you calculate on the map will be 100% correct, but only in Indian context. If you use the Indian projection system and try to place the location of let's say something like in US, it will not work, because when you will see the projection, you will see that India will be in the center and the entire world is distorted. And that's the idea of selecting a projection system. When you are working on a local projection system, you will get the best result in your local area, but when you will work on a global projection system, you will get fairly good result across the globe. So that's the trade-off that you will have to think about. Now when it comes to QGIS has already figured that out, and you can change the projection of your map anytime you want. So so we will just go to QGIS and then we will see. So in your QGIS, at the very bottom left, you will see something written as EPSG 4326, which is a global level projection system. When you will click on it, you will see this dialog box which opens up and which will allow you to change the projection system to the way you want. Now just for this simple example, let us put 32643 in the filter. 32643. If you don't have it over here, you can just put it over here. Okay. So we'll put 32643. And when you will do that, you will see that in the representation over here, you can see that this projection system is only valid for this part of the India. You know, so if your data is somewhere over here in the very west or in the very east, it will not work. We'll just simply keep 32643 and click on apply. Okay. Okay. You might see that, okay, there is no visible difference what we have done. Now let's try to bring OSM. Yeah, can you zoom out? Yeah, more. Go to the world level. Yeah. So if you can see, the map looks way different than what it was, because now you can see that the map is trying to keep this thing in the center and everything else is distorted. This is obviously not how the other part of the world looks like, and so does this part. So you can see that the New Zealand, Australia, South Africa, so the entire African continent, everything looks distorted. But India is at the best possible projection. And this is the power of projection. So whenever you will be working on your projects, just before even starting to figure out, ask yourself, what is the scope of my work? If it is going to be local, try to find out which is the projection system that will work best in your favor. But if it is not, then just stick with 4326. You go to 4326. Yeah. All right. So this was about the projection system that you can set for your entire QGIS project. But what about a layer? So as Malcolm correctly mentioned, that every GIS data will have a spatial attribute and it will have a metadata attribute. That means spatial attribute means the location related information, and metadata can be anything other than location. So for example, in case of road, it can be the type of road, and other kinds of things. But one more thing that is there in the metadata, and that is projection. You all have Goa SRTM and Goa Village open. Can you click on Goa Village, right click on it and go to the properties? If you right click on it and go to the properties, you can go to the information tab, and here you will see the coordinate reference system. So this layer is in EPSG 4326, and that's why when your map projection is also EPSG 4326, it will sit perfectly. Just like that, you can also check the coordinate system of Goa SRTM. Again, you will click on that layer, then right click on the layer and go to the properties. Then under information, you will have to look for something known as coordinate reference system. So if you scroll down, you will see the CRS written as EPSG 4326. So this is how you can check the projection of your data as well as set the projection of your QGIS project. But it doesn't stop at that. QGIS, as I said, will allow you to also process your data. That means, let's say if you grabbed a global data set which is in EPSG 4326 and now you want to just use it for the Indian context. That means you want to use the projection system of 32643. In that case, you can just simply go to your layer, go to the Goa Village layer, right click, export, save feature as, and here I will just save my feature to the file that I want. So first click here and give the file name, let's say like a maybe like reprojected. In exercise 2, in exercise 3, you can do reprojected and save it. But here before saving, you can select the CRS, like in which projection system you want to save your data. So I'll put it as 32643. Alright, and I will simply click on OK. So what it will do is, it will convert my data from 4326 to 32643 and then store that data into the 32643 projection system. Now you can see that the data is coinciding with our 4326 dataset absolutely correctly, because both of these datasets are in fact in the Indian context. But now if you click on the properties of your reprojected Goa village, you will see that the system now is 32643. So this is how you can reproject the data. So now we will start with the exercises. So first thing I would like you to do is change your maps or your QGIS's original projection system. Pick up whatever country that you like, and just maybe you can just go to Google and search for projection system for New Zealand, like EPSG projection code for New Zealand or EPSG projection code for Germany, and you will get a list of these codes. So it's not like that single country will have single code. Like for example, in case of India, there is 32643 and there is 32644.
Okay. Reprojected underscore Goa underscore villages, save. Now remember, our objective is to change the CRS. So here we will choose the project CRS. If it is not available in your drop down, okay, 32643 is not available in your drop down, you can click on this icon on the side, okay, click, and you have a new dialog box where you can simply search for a specific CRS. So here you type the code 32643, which represents the CRS, the projected CRS which we intend to use. Okay, so you select OK. Now you can click OK. Remember, before you click OK, there is one button over here which says add save file to map. As a best practice, you can keep it checked so that the new data that you have created will automatically be available in your layers. Okay, there is a small checkbox, add save file to map. Keep it checked so that the layer is immediately available for you. So now you click OK. Sana, click OK. So you will see now the new file name and is added to your layers panel. Okay, you can go ahead and check its CRS now. It will come in the projected CRS. Okay, so this brings to the end of this module. I expect you to be able to have your data in the reprojected system up to here. Now we will begin with the next exercise, georeferencing. Facing difficulty, please raise your hand. Facing difficulty, please raise your hand so that one of our volunteer can help you.
Okay, now we will do georeferencing, which will be also interesting. many of the times we have seen that when we, when we get older data, like if you remember earlier, for our property documents or any kind of maps, we used to get a PDF or a PNG or a photo or a hand copy or something like that, So even though there is a representation of, let's say, an area or a ward or a village on the map, but it's simply a page. So there is no geo-referencing done to that page. That means even though it shows the boundary correctly, and they have also given that the scale is, let's say, 1:10,000, but it does not have any kind of geospatial data attached to it. So what if I want to show, let's say, a ward boundary, a PDF or a photo on my map? So in that case, we will use the concept known as geo-referencing. So geo-referencing will be very useful whenever you want to do analysis work, because when you receive a non-GIS data like a photo of a village or the normal map that we get in a printed format, geo-referencing allows us to put that map into QGIS with the help of certain ground control points, which are known as GCPs. So we'll go to geo-referencing. Yeah. Geo-referencing. Come back. Yeah. So, no, this is day 2. Back. You are going. Go back. Wait. Yeah. So now we will see geo-referencing. So there are 2 ways we will be doing geo-referencing. One is image to map, and second is image to image. Okay. So that means if you know the ground control point. So let's say that you have received a photo, and along with the photo you know 3 or 4 ground control points. Let's say you have a photo of a village, and you know what is the most northeast part of that photo, northwest part of that photo, maybe southwest part and southeast part. So you have 4 coordinate system, 4 coordinates, and you have a photo. So in that case, let's see how do we do that. So can you go to the map? Yeah. First, let's start with a fresh project. So just simply click on new and discard this project if you want to, or if you want to save it, you can save it. Now the first thing that we will do is we will go to the raster. No, but we'll have to bring the image now. You have to bring the image now. Layer. Yeah. So we will start by adding the raster layer. So just click on raster layer. Now here you will select the PNG. You have to do PNG base, no? So for example, this is.
Can you open the folder only directly? Open from the folder only.
Yeah. So as I was talking to you, that let's say we have a photo. So for example, this is a very good example of the photo. Now I have this photo and I want to put this on my QGIS at a correct location, so that then I can do other things like digitization and everything. So to do that, first of all, we will go to our QGIS.
Okay, so we have a map of Goa here, which is having the latitude longitude grid. Okay, means we have some known points whose coordinate information we already know. Okay, so you will see that I will just open back the map. Can you open the map back? Okay, so if you see the corners of this map, right, just zoom into the corners, you will see it has the coordinate information, right? Using this information, which is of the specific coordinate, okay, so this specific point on the grid has these coordinates. Using this, as a ground control point, we are going to register this map onto the Earth surface or in our QGIS. Okay, so this is called as image to map registration. Okay, so we will use the four corners of this map and input the coordinate information. Okay, so to do this, we'll go to the QGIS now. There is a plugin which is a core plugin of QGIS called Georeferencer. Okay, so Georeferencer is the plugin that allows us to perform this function. Okay, image to map registration. So you will find the Georeferencer plugin under layers, then Georeferencer. Okay, so don't do it now because this is a very critical exercise. Don't do it now. We'll give you a chance to do it with us. Okay, so you go to Georeferencer. Now there is a add raster button there. So you click that button, go to the file where the map is stored. Remember, this map is not georeference, it doesn't know where it belongs on the surface. Okay, so we are going to select that and click OK. Now you have it in your Georeferencer plugin. Now, as a best practice, what I usually recommend is you write the coordinates of each of the corner on your book and keep. This is what I recommend usually. Okay, and then we start adding the coordinates in a circular manner. Okay, now before we begin, there is another important piece of information that we need. That is the CRS of that map. Okay, so usually you will go somewhere and you will find on the map what is the projection. Okay, so it's saying WGS 84. Okay, and latitude longitudes are given in WGS 84, which is 4326. Okay, so now let's zoom out. Okay, so in the Georeferencer plugin, by using the corner points as ground control points, I will begin georeferencing process. So I go here, zoom in first. Now to add the ground control point, okay, I will choose an option, add ground control point. Okay, no, not load GCP, add point. Close this. You have already selected add point. Okay. Okay, so now you zoom in to this corner, okay, and click on exactly the intersection of the grid. Okay, now a dialog box will open which asks you X east and Y north. Remember, X is always the longitude and Y is always the latitude. Okay, don't do it now, please don't do it now. I'll give you time to do it. Okay, so in the X you will put the longitude. Okay, longitude is read from here directly, which I said as a best practice you can write it first only. So 73, that is degrees, space, you can put space to separate degrees and minutes, and then 45. So she's put 73 space 45, and for the latitude 15 degree 30 minutes. Okay, so 15 space 30, and here you need to assign the correct CRS. So in this case 4326. Okay, WGS 84 4326. UTM 4326. 4326. Yeah. Okay, and click OK. So this is one ground control point we have added. So we have to choose ground control points such that they are spread across the map, covering almost the entire area. So since we are using a topo sheet here, we'll take the corners of the topo sheet. So go to the next corner, click right at the intersection, add the latitude longitude value. So similarly she will do this for all the 4 points. Okay, so what is happening here is we are identifying points on the map and assigning those points the coordinate value. That is what we are doing. Okay, so you can go clockwise or anti-clockwise. Don't try to jumble. Okay, if you put the wrong value in the wrong place, your map will not come on the right place, it will go somewhere else. Okay, so you have to do it meticulously and carefully. So now that we have established 4 points, okay, there are some more important steps to be done. Okay, since this operation or the process is a mathematical process of taking the map, which is not knowing where it belongs, and then putting it onto the earth. So basically what we are trying to do is taking this, imagine this is like a rubber sheet, we are taking it and putting it properly on the earth. Okay, so this is a mathematical operation. So there are some settings. So we go to the transformation settings, we set the transformation type. Okay, so here we'll set polynomial 1. Since this is a straightforward map, it doesn't have much distortion, we can choose this algorithm. Okay, sometimes you might have an aerial photo which has some distortions, right? So accordingly you may choose a different transformation. Okay, so for topo sheet, polynomial 1 usually works. Target CRS will be 4326. Output file name is what you need to assign. So again, as a good practice, you can keep the original name and add a suffix or a prefix. So here we are saying West_Goa, we are adding modified, okay, to mean that this is georeference. Okay, click save. Now we can directly ensure that you keep save GCPs. So if at all you need to change, add more GCPs, you can keep that. Load in project when done, check, and okay. Now everything is done. You will see we have got some values over here. Okay, so here the last column says residuals, right? This is actually showing you the error. Okay, now it is best to keep this number minimal. Okay, less than 1 is ideal, but remember when you click that intersection, right, you might go here and there somewhere always. Okay, so a value of 2 also or less for this exercise is okay, but remember the lesser this value, the better is your georeferencing. Okay, so once our value is less than 2, if it is not less than 2, you need to change the ground control points. Okay, so now that we are ready to georeference, there is a small play button there, green color, you click that and minimize this, and our map is now georeference. Now how do you know it is georeference? Let us add another data set to compare this. Okay, so we'll use the quick map services plugin which we had learned earlier and add a Google base layer. Okay, Google base layer satellite. Yes, so you can see now, zoom out. Can you see it's located on Goa, right? Yes or no? It's located in Goa, India. Zoom out a little more. Right? Now to check the accuracy of this map, whether it is really proper or no, just zoom in to some part. Can you zoom in? Zoom in. Okay. Now click on Goa. Okay. Click on this small style icon. Okay, properties, symbology, transparency, and you can reduce this transparency. Click apply. Okay, so you can compare this with the Google base layer. Okay, so I'll show you one way to compare is, we have a lot of shortcuts in QGIS. So I'm just selecting the layer, I'm selecting on this, click on this brush icon. Okay, let me move this to the side. There is an option called transparency, so I'm just reducing the transparency. Can you see the roads shown on the map and the roads you see on the Google satellite imagery? They are matching. Right? So you know how accurately you have georeference. So this, what you have done here, taken a simple output, assigned coordinates, and then placed it on the map in the correct position, and then checked whether it is done properly or no. So this is called as image to map registration, right? So now that you've understood what image to map registration is, we will do it step by step, very meticulously. Okay, so Sia will be here, she will show you the steps one by one, and we will also help you. Okay, so let's go. So, to start, blank slate, new project. Okay. So we are starting with a clean slate. Close the georeference apply. So we are starting with a clean slate here. Let's go to layer and georeferencer. Everybody, layer, georeferencer, click. Yeah. So you have the georeferencer plugin. Let's add the raster topo sheet which you have that we want to georeference. So you have to click on that add raster button on the top left. Open raster. Navigate to the raster file. Okay, let me see. You have two projects. Where is the file? I'll just close this one. Exercise 4. Data. West Goa. So you will go to layers, georeferencer, open raster layer, navigate to the correct folder. So that correct file is located in exercise 5, right? Exercise 4. So the folder exercise 4 has a file called west_Goa. So you select that file, you will see it available in the georeferencer plugin, right? So everybody, I want you to be on this page. Anybody who is not on this page, please raise your hand so that a volunteer can assist you. Anybody who is not here, close this. Anybody who is not here, please raise your hand so that a volunteer can assist you. Okay, great. So let's start adding the ground control points. So as I mentioned, a best practice is to write the coordinates on your diary of all the corners. Okay, if you can remember, not a problem. Try to zoom in to the corner as much as possible with your mouse wheel and click exactly in the center. Okay. So first, before that, you need to click on this add point button. Okay. So you are adding a ground control point. So there is an add point button there. Click the add point button. Your cursor will turn into a cross mark. Okay. There is an add point button over here. Click that. Your cursor will turn into a cross mark. Now click on the intersection. Exactly in the center. Now for the X, add the longitude value. Longitudes are always mentioned here on top. Okay. So longitude here is 73 degree 45 minutes. To add it, 73 space 45. 73 space 45, and in the Y 15 space 30. And then make sure you assign the correct CRS. So here the CRS is 4326. Okay. And then you click OK. Now go to the other corner and do the same exercise for all the 4 corners. Come on, go ahead. So we are adding the ground control points to all the 4 corners. You don't have to add the symbol degree and minutes, you have to use only space. Okay? Use space. To add points, there is an option add point. Once you click on add, the cursor will turn into a cross. Okay, then you can mark and add the points. Okay, I want you to quickly finish adding the ground control points for all the 4 corners. Okay, please add the ground control points for all the 4 corners. Okay, I'll give you 2 more minutes. Add the ground control points for all the 4 corners. Make sure the CRS is 4326. Okay. Has everybody added 4 points? Anybody who has not added 4 points, please raise your hands. Not added 4 points? Anybody who has not added 4 points? Okay, how many are remaining to add 4 points? Okay, so now I want you to pay attention. Okay, so now that we have added the ground control points, we need to assign the transformation settings and the CRS. Okay, so to do that, we will click now on the gear icon. Okay, so click on the gear icon. Go ahead and click on the gear icon. Then you will see a new dialog box. Okay, so in this dialog box, the first parameter is transformation type. We set it to polynomial 1. Now there are several algorithms. Each one have their own advantages depending on what your data set is like, whether it's distorted or no. So for this, Toposheet will use polynomial 1, and here the target CRS will be set to 4326. Okay, and you need to set the output file location and name. So to do that, click on the 3 dots, and as a best practice, you retain the name of the file and either add a suffix or a prefix. So in this case, you can name it as Goa West underscore georeferenced. Okay, or by default you can say Goa West underscore modified. I would prefer to name it Goa underscore West underscore georeferenced. Okay, save it in your system. Okay. You can keep this checked. Okay, just in case if you have to alter some GCP values, if you have put them wrongly, you can directly add it instead of adding all over again. Okay, and check load in project when done. Once you have done all this, you can go ahead and press OK. Okay. So now that we have set the transformation settings, click OK. Now you got to check your residual values. So last time you saw the value was above 1. This time we did slightly better and the value is now below 1. Means we did a better job than the last exercise. Okay. So you have to see that this is not big value. Anybody who's got a value which is very big here, raise your hands. Anybody got a very big value here in the residual? Okay. Which means you have missed or interchanged some values. Okay. And you will have to do the GCPs again. Okay. So for those of you, rest of you who have this value below 2 for this exercise, go ahead and click the play button, green play button which you see on the top left. So here you will, the georeferencing, if it is successful, you will see a new layer being added to your map. Now many a times there can be a lot of errors you may face over here, and that's not uncommon to face errors when you are georeferencing. Okay, it can be for various reasons, so don't get panicked. You may have to try it again. Okay, so it often happens that you may not get the correct result over here. Okay, so it's perfectly alright. Takes a little bit of practice to get it right every time. Okay, it happens that you have not put the value correctly, interchange the values. Okay, mark the point in the wrong place. So a lot of things can happen. You have to repeat the exercise. You have to repeat the exercise of marking the ground control points. So how many of you were successful in generating the georeference raster? Raise your hands. How many were not successful in generating a georeference raster? Okay. Okay. So I would suggest those who could not get it to practice, you have the step-by-step guide and you will get it right. Okay. So once you have got the georeference raster, or those of you who have got the georeference raster, go ahead and add another data to cross verify. Okay, so go to web, go to quick map services and add the Google satellite layer at the bottom. So go ahead and add it. So go to web, go to quick map services, Google satellite, add the layer. Okay, so do this step. Now I'll show you a quick tip. Okay, so a quick tip is you can select the layer here in the layers panel. Okay, and there is a small tool here which say under the layers panel, okay, which says open the layer styling panel. Click on that and you will see a panel. Now that panel may come anywhere on your screen. Okay, you can simply move it to the right side and it will remain over there. Okay, that's the beauty of QGIS. You can organize these panels wherever you want. Okay, and I like to have my layer styling panel docked over here on the right. Okay, so again I will repeat. Select the layer in the layers panel, click on this small brush icon, whatever you will get the panel. Okay, that panel you can drag around anywhere and place it wherever you like. I prefer it on the right side, so I'll just put it over here. Okay, and there is a tab here. Okay, the second tab which says transparency. Okay, and there is a slider right next to it. You move this slider and you will see in real time the layer getting transparent. Okay, so it's a good way to compare with any other data set. So I'll just compare and zoom into any location and move the transparency slider to check my georeferencing. Right, so you will see the roads coinciding or the boundary matching the boundary on the Google base map. So go ahead and check how good you are able to georeference.
After georeferencing, we have to close it.
Yes, it's a best practice to cross check how well you have georeference. So you need another data set which is already georeferenced. So in this case, we are taking the satellite, Google satellite data from the quick map services. Georeferencing झालं? Okay. So this layer came right. Yeah. So this is your georeference layer. Now to compare, you go to load another layer. So okay. So you can add the contributor pack. Okay. So when you do this, most services get contributor pack. You get the other data sets as well. Now you can just use this. Too many panels there. Understood? Okay, so I believe most of you have got it right. Some of you have faced issues. Okay, so it is quite common to face issues in georeferencing when you try it first time. Okay, you have to be very meticulous and you will get it right. Okay. Participants, now you hold on now. Okay, we will move. We want to demonstrate to you image to image registration. Okay, and we will. You can do these exercises at home, and come tomorrow. We will evaluate any issues you are facing and we'll solve them. Okay, but practice, practice, practice. Okay, practice will make you perfect. Okay, so we are running a bit short on time. So we will demonstrate to you step by step for image to image registration, and then you can do it at home. Okay. So now I want you to stop doing any exercise. Okay, right now, because how to do it, the steps are there for with you all the time. Okay. So we will just demonstrate to you now image to image registration. So shall we begin? I need your attention. Okay, now stop, Samuel. Yeah. So first I will explain to you what is image to image registration. Okay. Most often you will see data in the form of map which is shared, right? But it might not have the latitude longitude grid. Okay. Let me show you one example. Open the ODP plan. So we have the town and country planning department in Goa, right? It has the regional plans on its website. It has the outland development plans on its website. But they are often missing the grid information, which is actually required to georeference them accurately. But there is a process to georeference such maps, and that is called as image to image registration. So how do we do it? We have this ODP. We are actually going to do that. Okay. So we have this ODP of Margao, and it's going to be important for some of you. So we have just taken this down from the TCP website, right? Now I am from Margao. I know most parts which are represented on this map, right? But what about you? You might not be familiar with Margao, okay? So if you go on this map, right? Can you zoom into this intersection? Or this intersection, okay? So there are some road intersections here, okay? And I have marked some points so that it becomes easy for you to know where are the points, okay? So in image to image registration, what happens is we identify a point on this map, for example, this intersection, and we have another source which is already georeferenced, okay? Like for example, the Google base map, okay? And we identify the same point, this same point on that georeference map and take the coordinate information from there, and we georeference this map. Okay. So again I am iterating what we are doing. We are identifying a point on this map. Same point we are identifying on another data set. In this case the Google map, and we are using that. We are tying this point to that point. Okay. And that's how we are performing this georeferencing. So this is called as image to image referencing. So you need to have one source which is already georeferenced. So now we will demonstrate for this exercise how this is done. To make it more simple for you, I have already marked where the ground control points are located and I have labeled them. So there is one over here. Sana, can you show the other ones? So I have chosen road intersection Okay, there's one here. I have chosen road intersection because they are very specific, right? Very specific and very easy to identify. So using these points that I have identified, we can do the georeferencing. If you are doing this for your village, and I would suggest that before you come tomorrow, you try to download a map for your village and you try to do this exercise, okay, and come prepared. So this is a little bit of homework. So I don't like to give homework, but you can try this, okay. So now Sahana will demonstrate how we are going to do this, okay. So Sahana, go ahead. So we'll load a base layer. So in this case, we are loading Google satellite, which will serve as a base layer, okay. Then we go to layer, georeferencer, okay, and we'll load the map, okay, which is not georeferenced. Exercise 5. Okay, so this is a map which is not georeferenced. Now you go and zoom into one of the intersection points, okay. So here this is a point A, zoom in. Now you add the ground control point. Click right in the center, okay. Now hold on. Now we don't have the coordinate information, right, to put over here. So what we do, we choose from map canvas, okay. So click on from map canvas. Now we have to identify that specific point on this map, okay. So now, okay, now what will happen is she might find it a little difficult. So I have already marked the points. Can you load the geo package? So she would have actually had to go and look for that exact same point. Just to make this exercise quicker, I have already located the points and I put on the map, okay. Exercise 5. Solution? No, reference point. Go back. Yeah. Okay. Yeah. So just to make things easier, I have already located the points, okay. Otherwise, you would have to actually zoom in and locate. So point A is over here, road intersection, okay. Click. So now, wait. Now you have noticed automatically the latitude and longitude information is stored. And next is very important. Here it is asking for CRS. Remember, here you need to choose the CRS of your reference layer. In this case, the Google base map. So the Google base map has this reference system 3857 EPST code. Okay, click that and hit OK. Okay, now zoom out. So one point is done. Zoom out. Now find the next point. Go back. Go to here. Point B. So this point B is Kolva circle. Okay. So I know where the Kolva circle is. I'm sure most of you will also know. So click here. Click on from map canvas. Go to Kolva circle. So this is a Kolva circle near KDC bus stand. Everybody knows, right? So that's the point we mark. Now we'll choose OK. So mark all the other points. So one point here, D. This point I have already marked just to make it easy for you, okay? Just to understand the logic. So all these road intersections are taken, okay? One more. Yeah. Okay. So what Shana has done now is identified the points on the map. Same exact points she identified on the Google satellite imagery. Taken the coordinate information. Now apply the transformation settings. Okay, we'll keep polynomial 1 for this case. Okay. Target CRS you keep the same of the pseudo marketer. Okay. Click OK. Now click play. And it will begin georeferencing. So if we have done everything correctly, you will see now the map, the plan that was shared by the TCV department will now appear on the correct location, and you can then evaluate what is planned and what is coming where in Margao. Okay, so we are actually going to do that now, and I will just show you the results. So depending on your system, this might take a little time. Okay. Okay, zoom out. So now you can see it's georeference. Okay. Now, as a villager, suppose I am from Margao, I want to know what the government has planned in a particular location. I can simply check just like how I was doing. Okay. So I am sure many of you must have visited the Matani Saldana complex, right? Okay. So everybody knows collectorate office, right? So it's listed here on the plan. Now I will switch to the transparency, and let's see if Matani Saldana is there. Is it there? Right? This is the building, right? Iconic, you can know this, right? So now with regard to the plan, what you see here is some fields, right? I switch on. What do you see there now? As per the plan, there is something called as GSUDA Tech Hub, right? So now you know where it is coming on the ground, right? So what have we done? We have taken a plan, identified ground control points, and then put it on the map. Now it is georeference. We can compare it with any other georeference data sets. Tomorrow you can go on the ground, collect some data and put it here on top and know where it is on Google and also where it is on the plan. Okay. So we have demonstrated to you georeferencing, image to map, image to image. The only way to get better is to practice. So we will be winding this today's hands-on session at this point. I would request you have the guide, step-by-step guide, which is made for your benefit. You have the data set. Try it, practice it on your own laptop. Before you come tomorrow, before we start the session tomorrow, our volunteers will be there. You can have a one-to-one discussion with them and get all your doubts resolved. Okay? Because when we start tomorrow, we will build from here. When we start, we are not going to come back. Okay? Before we start, get all your doubts cleared. Am I clear? Okay? Because we are going to have a similar Power Pack session tomorrow, and I hope we are not going to be delayed in starting the session. Okay? And you will be preparing your first map, which you can publish. Okay? So I'm excited to see what you will come up with. So my closing comments would be to practice and come resolve your doubts before we end the session tomorrow. Over to Krishna for his inputs.
Yeah, I think tomorrow's session would be really exciting because we now know what are projections, we now know how to put a non-GIS or non-georeferenced image and then georeference it. Tomorrow we will start with the digitization, which will essentially means that we will create our own vector data set. Like so far we had this Goa village map, we just dragged and opened that on our QGIS. But what if you want to create your own layers that you want to display on the map? That is what we will be doing tomorrow. So yeah, I think all the best, and if you guys have any question during this conference, you guys can reach out. Sorry? I will be at the same time. 3 o'clock, right? 3 o'clock. 3 o'clock. Yeah. So after lunch, immediately you will, or no?
Yeah, we will begin this exercise over here in the lab at 3 o'clock tomorrow as per schedule. Okay? That's at least the intention we have. But our volunteers will be there tomorrow. Samuel will be here. So during the break or if you have any doubts, you can just walk in and discuss and get them cleared. So that when we start, because we are having a Power Pack session tomorrow, and we believe in having more time in analyzing your queries and questions than actually doing the step-by-step thing, because that you can do. right? So get your doubts cleared before we start the session. That's all I'm saying. Okay? So we wind up. Thank you very much. If you have any questions, you can ask, and those of you who want to leave can leave.
So before we go, I would like to tell about one of the course that we are planning to do in March. So I run an agency where we do software development as well as we do training in GIS. And specifically, we have this March batch coming up for GeoServer. For those who don't know GeoServer, it's one of the most widely used tool for hosting your geospatial data. So for example, so far whatever we have done, we are doing it in our local machine, like in our local computer. Everything that we will be doing, all the data that we will be creating will be on our local machine. But if you want to expose that to the world, and if you want to have better look at querying, styling and all, I think this can be an amazing tool. For those who don't know what is GeoServer, there is a free webinar that I'll be doing on 25th. So you can just scan this, and this will be a free webinar on LinkedIn. So whoever is on LinkedIn can attend it and understand. And those who wants to enroll into this cohort, they can scan another QR code and let us know. So we'll be more than happy if you guys have any questions if related to GeoServer as well as related to QGIS. So yeah, that'll be all. Thank you.